Question 61. What is a subtransmission network? A subtransmission network is the part of the power system that transfers electrical energy from the transmission network to distribution substations. It consists of substations, overhead lines, and underground cables operating at intermediate voltage levels. In the United States, common subtransmission voltages include 69, 115, and 138 kilovolts. In Europe and many other countries, 63 and 132 kilovolts are also commonly used. In summary, a subtransmission network connects the transmission system to the distribution system using intermediate voltage substations, lines, and cables. Question 62. What is a transmission network? A transmission network is the part of the power system that transfers large amounts of electrical energy over long distances between power plants, substations, and major load centers. It consists of high-voltage substations, overhead transmission lines, and underground transmission cables. In the United States, common transmission voltages include 115, 230, 345, 500, and 765 kilovolts. In Europe and many other countries, 132, 230, and 400 kilovolts are commonly used. In summary, a transmission network is a high-voltage system used to transmit electrical power efficiently over long distances from generation sources to load centers and distribution networks. Question 64. What is a subtransmission dispatch center? A subtransmission dispatch center is a control facility responsible for monitoring and controlling subtransmission networks and distribution feeders within a specific service area. Its main functions include supervising substations, monitoring power flows, coordinating switching operations, managing loads, and responding to network disturbances. In the United States, Europe, and many other countries, the voltage levels under the control of these centers vary depending on utility standards and network design. In summary, a subtransmission dispatch center supervises and controls subtransmission systems and distribution feeders to ensure reliable power delivery. Question 65. What are power transmission lines? Power transmission lines are high-voltage electrical lines used to transfer large amounts of electrical energy from power plants to substations, major load centers, and interconnected power systems over long distances. They also provide interconnections between regions and help improve the reliability and stability of the electrical grid. In summary, power transmission lines are the backbone of the power system, carrying electrical energy efficiently from generation sources to consumers and interconnected networks. Question 63. What is a regional dispatch center? A regional dispatch center is a control facility responsible for monitoring, coordinating, and controlling the operation of the transmission network and power generation resources within a specific geographic area. Its main functions include maintaining system reliability, balancing generation and demand, monitoring power flows, coordinating switching operations, and responding to system disturbances. In summary, a regional dispatch center supervises and controls the power system within a specific region to ensure safe, reliable, and efficient operation. Question 66. How are power networks classified according to voltage level? Power networks are generally classified into three main categories based on their operating voltage levels. Transmission networks carry large amounts of electrical power over long distances. Subtransmission networks transfer power from transmission systems to distribution substations. Distribution networks deliver electricity directly to residential, commercial, and industrial consumers. In the United States, common transmission voltages include 115, 230, 345, 500, and 765 kV. Sub-transmission voltages commonly include 69, 115, and 138 kV. In Europe and many other countries, common transmission voltages include 132, 230, and 400 kV, while sub-transmission networks often operate at 63 or 132 kV. In summary, power systems are divided into transmission, sub-transmission, and distribution networks according to their voltage levels and functions within the electrical grid. Question 68. What types of conductors are used in overhead transmission lines, and which type is used most often? The most common conductors used in overhead transmission lines are copper conductors and aluminum conductors. Today, aluminum conductors are used more widely in high-voltage transmission systems because they are lighter, more economical, and suitable for long-distance power transmission. To improve their mechanical strength, aluminum conductors are often reinforced with steel strands at the center. This type of conductor is commonly known as aluminum conductor steel reinforced, or ACSR. In summary, both copper and aluminum conductors are used in overhead lines, but aluminum conductors reinforced with steel are the most widely used due to their lower weight, lower cost, and high mechanical strength. Question 69. Why is high voltage used for power transmission? High voltage is used for power transmission because, for the same amount of power, increasing the voltage reduces the current flowing through the transmission line. Lower currents significantly reduces conductor heating, power losses, and voltage drop along the line. This makes the transmission of electrical energy over long distances much more efficient and economical. In summary, high voltage transmission reduces current, minimizes losses, reduces voltage drop, and improves the overall efficiency of the power system. Question 70. What is the nominal voltage of a transmission line? The nominal voltage of a transmission line is the designated operating voltage for which the line and its equipment are designed. The insulation of energized parts must be capable of safely withstanding this voltage during normal continuous operation. In power systems, nominal voltage is usually expressed as the phase-to-phase voltage, also known as the line-to-line voltage. In summary, the nominal voltage is the standard operating voltage of a power system and is typically specified as the line-to-line voltage of a three-phase network. Question 71. How are transmission lines classified based on length? Transmission lines are commonly classified into three categories based on their physical length. A short transmission line has a length of less than 80 kilometers. A medium transmission line has a length greater than 80 kilometers and less than 240 kilometers. A long transmission line has a length greater than 240 kilometers. In summary, transmission lines are classified as short, medium, or long lines according to their length, which influences their electrical characteristics and analysis methods. Question 72. What are some electrical characteristics of transmission lines? Transmission lines have several important electrical characteristics that determine their performance and power transfer capability. Some of the main characteristics are: conductor resistance, inductive reactance, capacitive reactance, nominal voltage, rated current, susceptance, surge impedance. Surge impedance loading, also known as SIL. In summary, the electrical performance of a transmission line depends on parameters such as resistance, reactance, voltage, current, surge impedance, and SIL. Question 73. What mechanical forces act on transmission lines? Transmission lines are subjected to several mechanical forces during operation. The main mechanical forces are: the weight of the conductors, the weight of accumulated ice, wind force acting on the conductors and towers, These forces affect conductor sag, mechanical tension, and the structural design of transmission towers. In summary, conductor weight, ice load, and wind load are the primary mechanical forces that transmission lines must withstand. Question 74. What is a transmission tower? A transmission tower is a structure used to support overhead conductors at a safe distance above the ground. Transmission towers are designed to withstand mechanical loads and environmental conditions such as conductor weight, wind, ice accumulation, and other external forces. They ensure that conductors remain properly supported and maintain the required electrical clearances. In summary, a transmission tower is a structural support that carries transmission line conductors and safely withstands mechanical and environmental stresses. Question 75. What is a dead-end tower? A dead-end tower, also known as a terminal tower, is installed at the end of a transmission line or at special locations where the conductors create significant unbalanced mechanical forces. Because the conductors pull from only one side, the tower must withstand high one-sided tension loads. For this reason, dead-end towers are heavier and stronger than ordinary suspension towers. The insulator strings used on dead-end towers are installed in tension configuration to support the conductor pulling forces. In summary, a dead-end tower is a heavy-duty transmission tower used at line terminations and locations with high unbalanced mechanical tension. Question 76. What is a tangent tower? A tangent tower is a transmission tower used on straight sections of a transmission line. In this type of tower, the conductors continue in a straight path, and the mechanical forces on both sides of the tower are approximately balanced. The insulators are installed in a suspension configuration, allowing the conductors to hang freely from the tower crossarms. In summary, a tangent tower is used on straight transmission line routes and supports conductors using suspension insulators. Question 77. What is the purpose of a guard wire on transmission lines? A guard wire, also known as a shield wire, is installed above the phase conductors of a transmission line to protect the line from lightning strikes. When lightning strikes the transmission structure, the guard wire intercepts the surge and safely directs the current through the tower and grounding system into the earth. This reduces the risk of damage to conductors, insulators, and electrical equipment. In summary, a guard wire protects transmission lines from lightning by intercepting strikes and safely conducting surge currents to ground. Question 78. What are sag and span in a transmission line, and how are they related? Sag is the vertical droop of a conductor between two transmission towers caused by its weight. Span is the horizontal distance between two consecutive transmission towers. The amount of sag increases as the span length increases. In transmission line design, sag is directly proportional to the square of the span length. In summary, span is the distance between towers, sag is the conductor droop, and sag increases significantly as span becomes longer. Question 79. Why are transmission towers grounded? Transmission towers are grounded to provide a low-resistance path for lightning currents and fault currents to flow safely into the earth. If a tower has high grounding resistance, a lightning strike can cause a significant rise in tower voltage, increasing the risk of flashover and insulation failure. To minimize this problem, ground rods or earth electrodes are installed and connected to the tower structure, reducing the grounding resistance as much as possible. In summary, transmission towers are grounded to safely dissipate lightning currents, reduce tower voltage rise, and improve system reliability. Question 80. What is a jumper and where is it used? A jumper is a flexible conductor used to provide electrical continuity between conductors located on opposite sides of a dead-end tower. Because the conductors are mechanically separated by tension insulators, the jumper allows electrical current to continue flowing through the transmission line. In some applications, particularly on lower voltage transmission and sub-transmission lines, jumper arrangements may also help reduce conductor vibration. In summary, a jumper is a conductor used to electrically connect line conductors across dead-end towers while maintaining mechanical separation.